Welcome friends. In our previous lecture, we have learnt about continuous casting process. Now today let us learn about centrifugal casting process. Now the question is, what is this centrifugal casting process and when it was started? So this was developed by A.G. Eckhart in England during 1809. Now what is its principle? It utilizes the centrifugal forces caused by rotation to distribute the molten metal to the mold cavities. As the mold is rotating, molten metal will be distributed into the mold cavities. So because of the centrifugal force, the molten metal will be sticking to the mold. That is how we get the required geometry of the casting. So this is the simple principle of the centrifugal casting process. Now these are the types of centrifugal casting process. One is the true centrifugal casting process. In this again we have two classifications. One is the horizontal true casting centrifugal casting, and the other one is the vertical true centrifugal casting, and the second category is the semi centrifugal casting process, and the third one is the centrifuging process. So first we will see the true centrifugal casting process and also the horizontal true centrifugal casting. Now what is this true centrifugal casting process? What is the principle? The mold is rotated about a horizontal or a vertical axis, and the molten metal is held against the walls of the mold by centrifugal force until it solidifies. The mold is rotated about a horizontal or a vertical axis. As it is rotating, molten metal is held against the walls of the mold. Now true centrifugal casting is used for the production of cylindrical hollow parts. So this is the main application of the true centrifugal casting process. Now here we can see the principle. Yes, here the molten metal is being poured, and this is a metallic mold, a cylindrical metallic mold we can see here, and it is supported using rollers. Here there are the top rollers and here there are bottom rollers. As the top rollers and the bottom rollers are rotating, even this metallic mold will be rotating. Now it is that time the molten metal will be poured into the mold, and during pouring the mold will be rotating at a predetermined speed, and this rotation continues till the molten metal inside this metallic mold solidifies. After solidification, the rotation of the mold stops, then we get the solidified cylindrical hollow casting. So this is the motor which drives the metallic mold, and here we can see the more details of this setup, and here we can see this is the ladle and this is the pouring basin, and here we can see this is the metallic mold, this is the cylindrical metallic mold, and here we can see these are the bottom rollers on which the metallic mold is supported, and these are the top rollers. Now this is the metallic mold, and yes, we can see as the molten metal is being poured, the metallic mold will be rotating, and this rotation continues till the solidification of the molten metal will be over. After that, yes, we can stop this rotation of the metallic mold. Then what happens? We get a finished casting like this. This is a hollow cylindrical casting. So this is an example of the centrifugal casting process, and here we can see the animation. So this is the metallic mold, the cylindrical mold, and here the molten metal is entering. As it is entering, the molten metallic mold will be rotating, and the molten metal will be sticking to the walls of the mold, and the rotation continues till the molten metal solidifies. Then the metallic mold will be detached, and we get the solidified casting. So long parts are produced using horizontal centrifugal casting process, and here this is the true photograph of a true centrifugal casting process. Here we can see this is the metallic mold, this is the metallic mold, and this is the ladle through which molten metal is coming to the cylindrical metallic mold, and here we can see these are the bottom rollers, and here is one roller and here is another roller. On the other sides also there will be two rollers, and at the top also sometimes there will be rollers, and as these rollers are rotating, the metallic mold will be rotating. It is that time the molten metal will be entering into the metallic mold, cylindrical metallic mold. So far we have completed horizontal true centrifugal casting. Now let us see the vertical true centrifugal casting process. Now why we should go for the vertical true centrifugal casting process? Why not the horizontal true centrifugal casting process? This is used, right, for heavy parts whose diameter is more important than the length. At such times we use the vertical true centrifugal casting process. The same principle is the same. There will be a cylindrical mold will be there and it will be rotating, but here the diameter is more important than the length. And here we can see this is the rotating mold, and the molten metal is being poured. As the molten metal is entering into the mold will be rotating, and this rotation continues till the molten metal solidifies inside the mold, metallic mold. And here we can see the animation. Yes, this is the metallic mold, vertical, and it is rotating about a vertical axis, and the molten metal is coming like this because of the centrifugal force, and it will be going to the sides of the mold, it will be going towards the walls of the mold, and this rotation continues till the molten metal solidifies. Now true centrifugal casting is carried out as follows. First step is we have to apply the ceramic slurry to the mold wall, because it is possible that the molten metal may stick to the metallic mold. So that should not happen. To prevent this, we apply a ceramic slurry to the mold wall, and it should be dried and also it should be baked. Next step is rotation of the mold at a predetermined speed, and it can start from 300 rpm to, and it can go up to 3000 rpm. Then once this mold keeps on rotating at this predetermined speed, we have to pour the molten metal into the mold. And most surprising thing is here no gating system is required. We have seen the design of the gating system for a sand mold, and also we have seen the die casting. Here no gating system is required. The mold is stopped after the casting has solidified. Till that time the mold has to rotate. Then the next step is extraction of the casting from the mold, and finally the next step, final step is the finishing. Means what is that? Removal of impurities at the center using machining, grinding or sandblasting. Now in the molten metal there will be some impurities will be there. So these impurities will be subjected to lesser centrifugal force. As the mold is rotating, the particles having lesser dense, they are subjected to lesser centrifugal force. So that is how they are collected at the center. So these are to be removed using machining, grinding or the sandblasting. Now what are the advantages of the true centrifugal casting process? Flexibility in casting composition. Of course there is an exemption, right? So maybe that exemption is for 0.4 to 0.85 carbon due to segregation. The next advantage is the wide range of available product metallurgical characteristics. We can get different types of the hollow cast components, and also we can get different metallurgical features and can form very large parts. The next advantage is central core is not required for making a hole or pipe, and we know that in the green sand casting, if we want a hollow casting or if we want a hole inside a casting, we used to place a core. So this core has to be made, and that should be carefully kept inside the mold. Then we have to pour the molten metal. That is not enough. After solidification, we have to separate the molding box, we have to break the mold, then we have to separately remove the core. So all this headache is not there in the case of the true centrifugal casting process. We get the hollow cast components, we get the holes inside the cast components, but no core is required. That is the advantage. Next one, employments of gates and risers is not required. No gating system is there, we have seen. That is how 100% casting yield in many cases. Now the question is, what is this casting yield? Let us see. This is the definition for the casting yield. Casting yield means it is the ratio of weight of the casting divided by weight of the poured metal whole multiplied by 100. Remember that weight of the casting is not equal to the weight of the poured metal. If the weight of the casting is 100 kgs, we always pour more than 100 kgs, maybe 125 kgs or 130 kgs. So, weight of the poured metal is always greater than the weight of the casting. So, this is the casting yield. Casting yield means weight of the casting divided by weight of the poured metal multiplied by 100. So, this should be maximum if the industry has to get benefit. So, in the case of the green sand casting, the casting yield will be say between 70 to 80%, but it is never 100%. But here we get close to 100%, because there is no gating system. As the molten metal is consumed for the gating system, there will be this casting yield will be coming down. Next one, relatively very light impurities move towards the center, which can be removed easily. Now, the question is how to remove the impurities. If it is a green sand casting, the impurities will be inside the casting, but here the impurities are subjected to lesser centrifugal force. Because of that, they will be segregated to the center. Now, after solidification, yes, they can be identified and they can be removed by machining or by brushing or chipping. So, impurities removal is easier in the case of the centrifugal casting process. Next one, fettling costs are reduced. Fettling means unwanted elements. If there are any such elements, we need to remove them, like cutting up the gating system, riser. So, these are the fettling process. So, these are reduced because first of all there is no gating system. So, fettling costs are reduced and little scrap is generated, cost of production is less. Now, these are the disadvantages or the drawbacks of the true centrifugal casting process. First one is suitable only for axial symmetrical components, only for axial symmetrical and for making hollow components, not for all the components. Second disadvantage is more segregation of alloy component during pouring under the forces of rotation. Now, this is another drawback of the centrifugal casting process. If the generally we use the alloys. Now, in the alloys there will be different elements will be there. If the density of different alloying elements are almost close, there is no problem. Sometimes it is possible that the density of one alloying element will be very high and the density of another alloying element will be very less. At such times what happens, the element having highest density will be subjected to larger centrifugal force and the element having the lesser density will be subjected to lesser centrifugal force. Then what will happen? The element having the lesser density, it will be moving towards the axis or the center of the casting, and the elements having the higher density will be subjected to higher centrifugal force and they will be moving away from the center of the casting. That is how there will be segregation of the alloying elements in the centrifugal casting process. So, this must be handled very carefully. Next one, secondary machining is often required for inner diameter. Yes, in the inside the inner surface of the casting, all the impurities will be collected because they are subjected to lesser centrifugal force. So, these are to be removed, sometimes machining is required. Next one, centrifugal castings require very high investments, that setup is very costly and expensive. Next one, skilled laborers are to be employed for this process, right, because the mold is to be rotated at a predetermined speed and it all depends upon a temperature. For a particular temperature or for particular alloy, it has to be rotated at different speeds. So, this all comes by experience. So, to operate this setup, experienced and skilled workers are required. That is how the process will be costly or it becomes expensive. Next disadvantage is the inaccurate internal diameter, and finally another disadvantage is the long lead time may happen. So, these are the drawbacks or the disadvantages of the true centrifugal casting process. Now, what are the applications of true centrifugal casting process? Manufacture of pipes, bushings, nozzles, bearings, inner liners for IC engines, bimetal, steel, bronze bearings and so on. Now, what are the materials cast? Alloy steel, carbon steel, cast iron, stainless steel, aluminum, copper, nickel. Now, let us see the part size. Diameter varies from 0.25 meters to 3 meters. You can see the diameter can be 3 meters, means very large, and length up to 15 meters and weight up to 5 tons, means small castings can be made and very big castings can be made. Now, these are the components produced by true centrifugal casting process. You can see here these are the hollow tubes or the hollow components, cast components are produced by true centrifugal casting process. We will see some more. Yes, these are the tubes or the components produced by true centrifugal casting process. Next one, again these are the components produced by true centrifugal casting process. Again these are also the components produced by true centrifugal casting process. Again we can see here these are also the components produced by true centrifugal casting process. Now, bimetallic pipes using centrifugal casting process. Bimetallic pipes can be produced by centrifugal casting process, and some bimetallic combinations are as follows. We can see here. So, these are the outer layer alloys, and these are the inner layer. For outer layer you can see 5% chromium steel, and for inner layer it is stainless steel. For outer layer stainless steel and for inner layer mild steel. For outer layer mild steel and inner layer copper. For outer layer mild steel and for inner layer aluminum. For outer layer it is copper and for inner layer it is GCI, and for aluminum outer layer and the inner layer is GCI. Outer layer is stainless steel and the inner layer is GCI. Outer layer is mild steel and the inner layer is nickel hard steel. Now, second metal is poured inside the mold after some time, and this time lapse after solidification for the first metal and before pouring of the second metal is calculated by D is equal to K root of T, where D is the thickness solidified and K is the solidification constant and T is the time. So far we have seen true centrifugal casting process and the two subclassifications within that. Now, let us see the semi centrifugal casting process. Now, what is this semi centrifugal casting process? Semi centrifugal casting, right, manufacture is a variation of the true centrifugal casting process. Yes, here also the centrifugal force will be applied on the mold and also on the molten metal, but there is a variation. What is that variation? What is the difference? The main difference is that in semi centrifugal casting process, the mold is filled completely with molten metal, which is supplied to the casting through a central sprue. In the case of the true centrifugal casting process, yes, no doubt there is a cylindrical mold and it is rotated, but finally the cast component will be hollow, there will be a hole inside. But here in the case of the semi centrifugal casting process, we will not get the hollow components. That is the main difference. You see, again let us see, the main difference is that in the case of the semi centrifugal casting, the mold is filled completely with the molten metal. The forces generated by the rotation of the mold ensure the distribution of the molten material to all regions of the casting. Because of the forces generated by the centrifugal force, the molten metal will be uniformly distributed into the mold. And here we can see, yes, this is the revolving table will be there, and this semi centrifugal casting process, in this process the mold will be rotating about a vertical axis always, and here there is a revolving table is there, and here we can see this is the molding box. Molding box means, yes, there will be drag means lower molding box, and there will be a cope, there will be means the upper molding box, and here there is the pouring basin, and this is the mold cavity. And as the mold is rotating about a vertical axis, the molten metal is being poured into the mold. Then what happens? As the mold is rotating, molten metal is entering, the molten metal will be subjected to the centrifugal force. So, it will be going away from the center. If there are any minute details, tiny details on the sides of the casting, yes, molten metal will be definitely entering into those tiny features. So, that is the advantage of the semi centrifugal casting process. And here we can see, so this is the pouring basin, and this is the cope, and this is the drag, and here we can see a component produced by the semi centrifugal casting. So, this is the wheel with spokes, and here we can see this is the pouring basin, and here internally we can see there are ribs are there, narrow ribs are there. If we cast this component using ordinary sand casting process, no doubt the outer part we may get, but the internal ribs it may not be possible for us. Sometimes there will be some discontinuities will be there, but these discontinuities can be overcome using the semi centrifugal casting process because of the centrifugal force that is falling on the molten metal. So, even this place where there may be some discontinuities, there also molten metal will be successfully flowing, and this is the semi centrifugal casting setup. Advantages of semi centrifugal casting process. In this, number of molds can be stacked together. One mold over the other can be fed by a common central sprue in order to produce more than one casting at a time. Means one mold can be placed over another mold, and all these can be connected by a central sprue, common sprue, and the molten metal can be supplied to all these molds at a time. Means at a time we can produce more than one casting. Second advantage is similar to true centrifugal casting, and hence it ensures purity. Poorer structure forms at the center of the casting, so this can be machined. If there is any impurity, again that will be collected at the center and that can be machined off. These are the applications of the semi centrifugal casting process. Wheels, you can see this kind of wheel. So, this is manufactured by semi centrifugal casting process. Pulleys, you can see here these are the pulleys. So, these pulleys are manufactured by semi centrifugal casting process. So far we have seen the true centrifugal casting process and the sub classifications within that. Then we have seen semi centrifugal casting process. Now, let us see the third classification of the centrifugal casting process, that is the centrifuging process. What is the centrifuging process and what is its principle? In centrifuging casting manufacture, molds employed to produce the desired castings are arranged around a central sprue. Here several castings at a time are manufactured within using a single mold. If it is the true centrifugal casting process or the semi centrifugal casting process, only one casting in a one mold, but here within a single mold there will be more castings. So, that is the special feature of the centrifuging process. These molds contain all the necessary geometry for the cast parts as well as the gating system. Runners travel from the central sprue to the mold entrances. This provides a means of increasing the filling pressure within each mold and allows for reproduction of intricate details. Centrifuge casting is often used in conjunction with investment casting process, because investment casting process involves manufacture of tiny castings, sometimes castings with not internal tiny features, intricate shapes, in which it is very difficult for the molten metal to enter or to penetrate. At such times we use the centrifuging process. Then what happens, as the mold is rotating, because of the centrifugal force that is falling on the molten metal will be passing through the tiny details. It is also used with molds made up of silicone rubber with sufficiently higher temperature resistance for repeated use in casting without mold deterioration. So, this process is known as the spin casting, means same thing, but here the molds are made up of silicone rubber. In such a case we call it as the spin casting. And cast materials for spin casting include zinc base alloys, lead base alloys, tin base alloys, aluminum and plastics. Now, here we can see the setup. We can see here there is again this also carried out about a vertical axis, similar to the true semi centrifugal casting process. But what is the difference between the semi centrifugal casting process and the centrifuging? In the case of the semi centrifugal casting process, there will be one mold will be there and it will be rotating about a vertical axis, but only one component is manufactured using one mold. But here there is only one mold, but there will be more components will be there. For example, this is one component, this is another component and this is another component. This is another component, means all along the circumference there will be several what say mold cavities will be there, each cavity meant for one casting. So, all these are cast at a time, all these are joined. So, after the solidification we have to remove, we have to cut, and we get so many castings at a time. And here we can see more details. You can see here this is the central sprue, and here this is the one casting, this is one casting, this is one casting, this is one casting. Likewise, there are several castings are connected to this central sprue. Now, when we pour the molten metal, as the molten metal is entering into this central sprue, it will be rotating, the mold will be rotating, and because of that there will be centrifugal force applying on the molten metal, and because of that, because of the centrifugal force falling on the molten metal, they will be passing through the tiny what say cavities. What are the advantages of centrifuging process? Ensures better quality. Castings when generated on large scale will be economical. Just now I have told you, in the case of the centrifuging process, using a single mold several castings can be made with one sprue, several castings can be made at a time. So, that is economical. Castings when generated on large scale will be economical. These castings generate high yield, because for several castings there is only one central sprue. So, the what say molten metal consumed for the gating system is very less, that is how casting yield will be higher. The castings obtained by this method cannot be satisfactorily obtained by other casting methods. The what say filling up of the mold by the molten metal is excellent because of the centrifugal force falling on the molten metal. Next one, cleaning and fettling cost of the castings can be reduced. Denser castings having physical properties similar to those of the forged products. Next one, rejection percentage is very low, because most of the castings are sound castings, no discontinuities. Next, finally, easy way to achieve directional solidification. This directional solidification we have already learned, so I do not want to repeat again. Now, let us see the centrifugal force. Centrifugal force acting on rotating body is Cf is equal to mv square by r, where m is equal to mass in kilograms, v is the peripheral speed meters per second, r is the radius in meters. Now, gravitational force Gf is equal to mg, where g is the acceleration due to gravity meters per second square. G factor is equal to Cf divided by Gf, that is equal to mv square divided by r into mg, that is equal to v square by rg. Solving further, we get n is equal to 42.3 root of g factor divided by t. So, this is the what say formula for the what say speed that is to be what say operated. Now, expected requirements of a centrifugal casting machine. What are the what say requirements? The machine must be able to accelerate the mold to a predetermined speed, maintain smooth spinning, and decelerate to a stop in a reasonable time frame. There must be a way to heat and coat the mold before pouring the molten metal. Otherwise, what happens? The molten metal may stick to the mold. So, to prevent this, we have to give a ceramic slurry coating. This must be dried and this must be heated, and also it must be baked. So, thus that much provision must be there within the machine. There must be a means to pour the molten metal safely into the rotating mold at a controlled rate, position and orientation. There must be a means of adding inoculants or fluxes for some special applications. The role of the inoculants and the fluxes we have already seen. So, even this centrifugal casting machine should have means of adding these inoculants and fluxes. Once the molten metal is poured, a proper solidification and cooling rate must be established in the mold to obtain a desired casting microstructure. Next one, there must be a means of extracting the solidified casting quickly from the mold at elevated temperatures without deforming the casting. Common mold materials. First, the most common mold material is the metallic permanent molds. So, these are widely used. Next one, refractory lined metal molds. Next one, sand lined metallic molds, and finally graphite molds. The metallic permanent molds are most widely used because of their reusability, accurate casting geometry and high productivity. So, these are the common mold materials. Among these, metallic molds are widely used. Now, let us see the defects in the centrifugal casting process. So, there are three types of major defects in the centrifugal casting process. One is the segregation banding, second one is the raining, third one is the vibration defects. First, let us see the segregation banding. Bands are annular segregated zones of low melting constituents such as eutectic phases, oxide or sulfide inclusions. So, these are the segregation banding. It occurs in true centrifugal casting generally where the casting wall thickness exceeds 50 to 75 millimeters. Banding is more prevalent in alloys with a wide solidification range. Minor adjustments to the casting operation variables such as rotational speed, pouring rate and metal mold temperatures will usually reduce or eliminate this defect. Now, let us see the second defect, that is the raining. Now, what is this raining? Raining is a phenomenon that occurs in horizontal centrifugal casting process. If the mold is rotated at too low speed, or if the metal is poured into the mold too fast, the metal actually rains or falls from the top of the mold to the bottom. Just like rain, the molten metal will be falling down. Why this is happening? Too low speed of the mold or too high speed of the pouring of the molten metal. So, these are the main reasons for the raining of the molten metal from top to the bottom. So, proper process control can eliminate the raining. So, that is why sometime back we have seen that to operate this process skilled laborers are required. Only those people, skilled people know at what say rotation there will not be any raining. So, if the mold's rotation is too low, there will be raining, or if the rate of entry of the molten metal is too high, that time also there will be raining. So, this can be controlled by experience. That is why experienced and skilled workers are required to operate this machine. Finally, let us see the vibration defect. What is this vibration defect? Vibration can cause a laminated casting and it can be reduced to a minimum by proper mounting, careful balancing of the molds and frequent inspection of rollers, bearings and other equipments. So, using these parameters we can minimize the vibration defects. Now, recent trends in the centrifugal casting process. Combustion synthesis in centrifugal casting. It is used to fabricate intermetallic components, metal and the other one is the ceramic layered components. So, to fabricate intermetallic components, this centrifugal casting process is used, in which there will be combustion based synthesis will be taking place. And here we can see this process in details using a diagram. So, this is the combustion synthesis in the centrifugal casting process. So, here we can see this is the reactor, and this is the sample container and this is the igniter which initiates the combustion. Now, this is the reactant mixture. Now, what will happen when this reactant mixture, because of this igniter will be reacting and there will be combustion inside the chamber, and because of that, as we have seen previously, we can fabricate intermetallic components, means where one layer is made up of metal and the other layer is made up of ceramic layered components. So, this is a recent trend, means using the combustion synthesis in the centrifugal casting process. And the next one is the using yes, in the previous case we were using the combustion, and instead of combustion why not electrical heating. So, that is the next development in this process. And here we can see, yes, this is the green compact and this is the mold part, and the third one is the alumina container, this is the alumina container, and the fourth is the heating coil, this is the heating coil, means this is heated using electricity. Fifth one is the thermocouple, and sixth one is the inner steel container. This is the inner steel container. Seventh one is the outer steel container. Eighth one is the electric source. This is the electric source. And ninth one is the graphite brush. This is the graphite brush. And 10th one is the slip ring. This is the slip ring. Now, the principle is same. We want to manufacture what say bimetallic parts, or the place where there will be components where there will be metal ceramic layered components will be there. Now, using the electricity, and there is a coil, heating coil, this will be heated up, and here there is a green compact is there, and because of that green compact, yes, this will be heated up and we get the required component. Required component means one layer will be metal and the other layer will be ceramic layered component. Now, with this we are coming to the end of this lecture. We have seen the principle of the centrifugal casting process, and we have seen the broad classifications of the centrifugal casting process. One is the true centrifugal casting process, the other one is the second one is the semi centrifugal casting process, and the third one is the centrifuging process. In the case of the true centrifugal casting process, there will be either horizontal mold or a vertical mold will be there, and these will be rotating at a predetermined speed, and the molten metal enters into these molds, but in this case we get a hollow component or a cast component with a hole inside. So, that is the specific feature of the true centrifugal casting process, and we have seen the semi centrifugal casting process. What is this? This is a variation of the true centrifugal casting process, and the mold always rotates about a vertical axis. But what is the difference between the true centrifugal casting process and semi centrifugal casting process? In the case of the true centrifugal casting process, we always get a hollow cast component or a cast component with a hole inside, whereas in the case of the semi centrifugal casting process, we get there will not be any hollow cavity will be there. We always get means the molten metal is always completely filled with the by the mold. And the third one we have seen, that is the centrifuging process. In the case of in both these two cases, semi centrifugal casting process and the centrifuging process, the mold will be rotating at about a vertical axis. Then what is the difference between semi centrifugal casting process and the centrifuging process? In the case of the semi centrifuging casting process, yes, there will be a mold will be there and it will be rotating about a vertical axis, but only one cast component can be produced using a single mold. But in the case of the centrifuging process, using a single mold, several castings can be made. And again, in the case of the semi centrifugal casting process, the cast component will have a symmetrical geometry, whereas in the case of the centrifuging process, the cast components may not have a symmetrical geometry. So, that is the difference between the semi centrifugal casting process and the centrifuging process. So, with this we are completing this lecture, and we will meet in the next lecture. Thank you.